In this video I'm going to examine the equations of constant acceleration. The equations of constant acceleration come about from a situation where an object is moving under constant acceleration. That is, the acceleration is constant, so the velocity will be increasing or decreasing depending on whether the acceleration is positive or negative. And we can plot this on a velocity time graph as a straight line. The gradient of the straight line gives us the acceleration, and we know that it's constant because it is in fact a straight line. If it wasn't constant, it would be a curved line. Now we can calculate the acceleration from the VT graph, from the velocity time graph, by just calculating the gradient of the straight line. So the acceleration is given by the change in velocity over the change in time, delta V over delta t, and we can see that that's a constant. Equation 1 follows from the fact that the acceleration is constant, that we can calculate that gradient. Examination of the diagram will quickly show us that the velocity at any time t is given by u, the initial velocity, plus the acceleration times time. Secondly, we wanted to look at the displacement, and the displacement of course is the area under the VT graph. So to calculate that area we can integrate equation 1 with respect to time. So if we integrate with the terminals between 0 and time t, we get the area equal to integral from 0 to t of v dt, and substituting equation 1 in there, of course, is the integral from 0 to t of u plus at with respect to time. If we do the integration, of course, we get ut plus a half at squared. That then gives us a formula for the displacement x at any time t, where x is equal to ut plus a half at squared. Moving on, if we substitute equation 1 now into equation 2, we can see that we get x equals ut plus a half outside of v minus u over x times t squared. Doing a little bit of arranging and collecting the like terms, we can see that we get to equation 3 where x is equal to a half outside of u plus v times t. And that gives us the displacement if we know the initial velocity, the current velocity, and the time. Moving along from equation 1, if we substitute that into equation 3, we get x equals a half outside of u plus v times v minus u over a. Doing a bit of manipulation and rearranging our equation, we end up with equation 4, v squared equals u squared plus 2ax. This means we can calculate the velocity v if we know the initial velocity u, and the acceleration and the displacement. Now we can use these four equations in various situations, and we'll have a look at some examples of how they can be used. That's a brief introduction to kinematics and the equations of constant acceleration.